So here we go with Algebra 1, Lesson 2.7. Today we're going to talk about rates, ratios, and proportions. Let's start with our warm-up. Hope everyone did it and you're good students. So in the first one, 6 times x, that means we need to divide by 6 to get rid of the 6. So x is equal to 6. Number 2, x divided by 4 equals 12. So to get rid of the 4, we multiply, since you heard me say it was divided originally. So 4 times 4 cancels. And then 12 times 4 equals 48. Okay. 5 times m equals 18. So inverse is to divide. Since it's multiplied, that we divide. Since 5 doesn't go into 18 evenly, just leave it as 18 over 5. R divided by 21. So that means multiply by 21. So R comes out to negative 63. 8 times y equals 18.4. So we divide by 8, get rid of it on this side. So y is equal to 2.3. Okay, on the last two, we need to multiply. 8 times 7 over 8. If it helps, you can think of this 8 as being over 1. So these 8s would cancel, and I just have 1 times 7, which is 7 over 1. So just leave it as 7. Okay, 12 times 5 over 6. Again, you can think of this as over 1. You can cancel. 6 goes into itself 1 time, 6 goes into 12 2 times. So now 2 times 5 is just 10, and we don't need to put it up over 1. If you want, you can, but we usually don't. Okay, so we're going to look at today writing and using ratios, rates, and unit rates. We're also going to look at how to write and solve proportions. So you need to understand what a ratio is. A ratio is a comparison of two quantities by division. The ratio of A to B is written either using a colon or A over B. B can never be 0 because we can never have 0 in the denominator. Ratios that name the same comparison are said to be equivalent. So for example, if I had just saying like 1 to 2 is the same thing as 1 to 2. They're equivalent ratios. Okay. A statement that two ratios are equivalent, so here we go, such as 1 over 12 equals 2 over 24 is called a proportion. So if I have two equivalent ratios set equal to each other, that's called a proportion. If I need to read a proportion, so let's say I have this here, this proportion here set up. So proportions have two fractions equal to each other, or two ratios equal to each other. I would read this as 1 is to 15, 1 is to 15, as x is to 675. So just ways to know how you should say it out loud. Okay, so we're going to practice writing a ratio. The ratio of the number of bones in the human ear to the number of bones is 3 to 11. There are 22 bones in the skull, so how many are there in the ears? So we're going to write a ratio of the bones in the ears to bones in the skull. Well, we know it's 3 to 11, so we'd write that 3 over 11. So if it helps, you could write ears over here and bones here, just so you know what's where. Now, we need that to be equal, okay, to what else we know. We need another proportion, or we need another ratio here. If there are 22 bones in the skull, okay, 22 bones in the skull. I guess I should have written skull. I shouldn't have written bones there. 22 bones in the skull, how many are in the ears? Well, we're going to let x be how many are in the ears. Now we can work this out, okay? The way we do that is to get rid of the 22, we multiply both sides by 22. So that cancels. 22 times 3 then comes out to 60. Or 22 to 3 comes out to 66 over 11, which simplifies to 6. So your answer is 6 bones in the ear. A rate, okay, new vocab, is a ratio of two quantities with different units. For example, 34 miles to 2 gallons is a rate, okay? A unit rate is a rate when the second quantity is 1. So, for example, 17 miles per 1 gallon. That's a unit rate when the bottom is 1. You can convert any regular rate to a unit rate, and we're going to look at that now. So, for example, okay, Ralph Lau of Germany flipped a pancake 416 times in 120 seconds to set the world record. Find the unit rate. Round your answer to the nearest hundredth. Well, first we need to set up a rate. We know he did 416 flips in 120 seconds. Now, the way to get this as a unit rate is to honestly just divide 416 by 120, okay? When you get your answer, you're going to get 3.47. Your units are flips per 1 second because you just divided it out. So again, we just did the flips per second and divided it, and our answer comes out to a unit rate of 3.47 flips per second. Okay, another new term, dimensional analysis. This is not the stuff people usually like, but I will tell you it is probably the most useful thing you will use. You'll use it through high school, you use it through college, you'll use it all the time, okay? So you need to learn how to use this. Dimensional analysis is a process that uses rates to convert measurements from one unit to another. For example, if I have 12 inches to 1 feet, where the quantities are equal but different rates, this would be called a conversion factor. A conversion factor is anything that tells us what's equal. So there are 12 inches in a foot. There are 100 centimeters in 1 meter. There are 60 seconds in 1 minute. These are all conversion factors, okay? We need those to convert rates from one unit to other units. So you're going to need to know your conversion factors. So let me just walk you through how you would do dimensional analysis. Okay. A fast sprinter can run 100 yards in approximately 10 seconds. Use dimensional analysis to convert the yards to miles. Round your answer to the nearest hundredth. Okay. Hint, there are 1,760 yards in a mile. So first, let's set up our first ratio. Okay, so the really important thing we need here is we need to know how to convert 100 yards to miles. So this is kind of to throw you off the 10 seconds. So whenever we have dimensional analysis, I always start by writing what I have. So I have 100 yards. And I always put it over 1. There's a reason. It just helps me to set up my fractions. I need to multiply it by a conversion factor, meaning something that will help me convert yards to miles. Well, I know in order for the yards to cancel, the yards have to be diagonal from each other. All right, well, we know that there's 1,760 yards in 1 mile. So these yards cancel, and I'm left with the units of miles on top. Well, the units are great, but how do we find the answer? Well, you're just taking 100 times 1, and then dividing it by 1 times 1,760. So 100 divided by 1,760. If you plug that in a calculator, which I know I tell you not to use, but you're going to need it for this, or you could just move the decimal place over. You're going to get 0.057 miles. Okay, just know that when I use yard, okay, here it appears to divide out, leaving miles as a unit. This is what I like to do. It's called dividing out units. I make sure that I have the right units directly across from each other so I know I've set it up correctly. So this is your conversion factor. For every 1 mile, there's 1,760 yards. All right, we're going to try a little bit more of a complicated one. A cheetah can run 60 miles per hour in short bursts. What is the speed in feet per minute? So we have 60 miles, and the last problem, it was just over 1, but this is per 1 hour. I need to get this into feet and minutes. I'm going to start by converting the miles to feet, okay? I'm going to tell you, because you maybe don't remember, that there are 280 feet in 1 mile. So I want my miles to cancel. So that means I need miles down here. Well, in 1 mile, there are 5,280 feet. So that allows my miles to cancel. How do I get my hours to cancel? Well, if the hours are in the denominator, I need them to be up here to cancel. Well, I want minutes. How many minutes are in an hour? Well, in 1 hour, there are 60 minutes. So this allows my hours to cancel, and I've got a feet per minute. Now, the way to solve this, you multiply straight across the top, you multiply straight across the bottom, and then you divide whatever your top is by your bottom. I've already done that for you, okay, so you don't have to worry about that. So the answer comes out to 5,280 feet per minute, or you could write it as 5,280 feet per minute. Another trick that you notice is these 60, they're diagonal. And I know it's across another thing, but you can still cancel diagonally like that. Okay, so my reminder to you for this dimensional analysis is that you want to make sure that the units are diagonal from each other so that they cancel. Okay, this slide kind of walks you just through that concept. You can check your answer to see if it's reasonable. They're saying, okay, there's 60 minutes in an hour, so 5,280 feet in a minute would be 60 times that, which is a pretty big number in an hour. They're just kind of showing you how to check your answer mentally. You can read through that if you want. All right, in this proportion, we're going to talk about now solving proportions using cross product property. In the proportion A over B equals C over D, the product A times D and B times C are called cross products. You can solve a proportion for a missing value by using cross products. You can only solve proportions this way when I have an equal sign in the middle. So I can multiply things diagonally and set them equal to each other only when I have an equal sign in the middle. So let's try some. Solve the proportion using cross products. All right, so I'm going to take 9 times 5, which is 45, equals 3 times m, which is 3m. Now I've got a nice simple equation. I can just divide by 3, and I get 15. All right, next one. I'm going to start with the easy one. 6 times 7. Okay, 6 times 7 is 42. This is a little tricky. 2 times y minus 3. You have to take 2 times the quantity y minus 3 so that it ends up being distributed to each part. Now I can solve, okay? I get 48 equals 2y, divide by 2, and I should get 24 as my answer. So just be careful. If you're cross multiplying and you have more than 2 things in the other part, that other number needs to get distributed to both of those, okay? All right, one last example. A scale is a ratio between 2 sets of measurements, such as 1 inch to every 5 miles. So you might have seen this on a map before. A scale drawing or a scale model, again, maps, globes, they have them on them. So a contractor has a blueprint for a house drawn to scale, where 1 inch on the map means 3, or on the blueprints mean 3 feet in real life. A wall on the blueprint is 6.5 inches long. How long is the actual wall? Well, let's do our proportion, our blueprint to our actual. Well, we know in our blueprint 1 inch means 3 feet. We want to set this equal to what is really going on. So in the blueprint, if I have 6.5 inches, because it needs to be the same on top, how many feet is this? So now we're going to use cross multiplication. When I cross multiply, 1 times x is just x, and x 6.5 times 3 comes out to 19.5. So the actual length is 19.5 feet, and you need to know which units they are. I know there was a lot in this lesson. Go back to sections to try to look at what I'm doing. I really think that this kind of stuff just comes with practice and doing the problems. So hang with me, don't give up. We're going to get through this, and I will see you guys in class.